Hello, Mr. Ryan, how are you? Yeah. Okay, so we talk about the graph. Yeah, the graph is the collection of vertex and edges, right? The vertex and edges. Yeah, graph can.
GVE.
Yeah. So for example, like this, the A vertex to B, C, and then let's say I have a D here. Okay, let's say, and then look if this is the connected unidirectional graph. Connected means that there is you can travel from any vertex to any other vertex, right? This is not connected, right? If I have an E here, this is not connected. So we're talking about a connected graph and unidirectional. Okay, sorry, unidirectional. It doesn't have the direction. So and I can put a weight on it. So let's say 1, 2. Okay, let's put it cycle here. Okay, 3, 4, 5. So I have a weight associated for each edges. Yeah, edges. What did I just say?
They have
Vertex and edges, and these are the
what I
weights.
said.
These are the weights, okay? So this one has a cycle, right? Because look, A, B, C, you can cycle, and B, C, D is also a cycle.
And TTE.
So look, a tree we know is a subset, right? The tree is a subset. Right? Tree doesn't have a cycle, remember? With tree doesn't know cycle, yeah? And then tree, we want to make a tree out of these graph. And it has to be connected, right? If it's not connected, if you don't have a you pick these, if you pick these, right, that's weight 1, that's weight 3. This is not connected, but this is a forest, yeah, because there are 2 trees, forest. We want to pick
that 2 tree.
Yeah, 2 trees for it. So we want to pick a single tree, 1 tree, so 1 tree connected.
I've got 3 trees with the forest.
Yeah, connected.
Not 2 trees.
And also we want to pick the edges that the sum of the weight, numbers of it are the minimized, are the smallest.
There are 5 edges.
Mean weight, okay? Mean total weight. Okay, so these are the requirements. And we call this tree what? Minimum spanning tree, MST. Minimum spanning tree. Okay, spanning. Make sense? So how would you draw a tree out of picking the vertex and edges? How would you do it? Okay, so first of all you have to pick all vertex, yeah? Pick all this.
But B's isn't in a circle. Yeah, now it is.
Okay, so which edge would you pick?
1, 2, 4.
Wow. 1, 2, 4. Yeah, this is the smallest. Okay, and look for if there are n vertex.
Wait, no.
Sorry?
1, 2, 3.
Oh yeah. 1, 2, 3. Okay, 1, 2, 3. Yeah, actually, yeah, this is better. Yeah. So if there are n vertex, how many edges would you pick? Huh?
N minus 1.
N minus 1. Why is that? If I pick n minus 1, I'll make it connected and no cycle. If I put 1 more edges, what happen?
Cycle.
That will be cycle, right? So we don't want a cycle, right? So for n vertex graph, so there will be n minus 1 edges, right? Am I right? Look, one vertex, no edges, 0. 2 vertex, you can only put 1, make it connected, 1 edges. 3, 2, right? Yeah, you can pick these or these or these. But if you add 1 more, there will be a cycle definitely, right? So n vertex, n minus 1 edges to make it no cycle, a tree, no cycle tree. And then you'll be making all the vertex connected, right? And then we wanted the spanning, the total minimum weight, so minimum weight. So how did you find out it's these, the 1, 2, 3?
Those are the minimum numbers.
Minimum numbers. Oh, okay. Okay. By luck, okay. How about if I change this to 10?
1, 2, 4.
1, 2, 4. Right. Yeah, easy. Yeah. Okay, so the weight, okay, we want to find the weight, minimum weight of tree. Sub-tree, T is a subset of graph, okay? And then these will be the weight of U to V, the vertex, yeah, U and V, U to V belongs to the edges, okay? So we want to minimize these, right? We want to minimize these. One way of doing this, okay, let's bring the topic today, which is called Kruskal. Kruskal diagram. Okay, so it's quite similar to how did you put it? How did you put it?
Addition.
Look. Okay, so this one. Yeah, what A, B, C, D. So first of all, the first step is to what? To create a to create a the we call it forest for each forest, and each one has no edge. So there will be 4 trees in the forest. Yeah. So F, let's say F. At the beginning, F belongs to an empty set. And then I need to add each tree, individual tree, the vertex, single vertex, right? So I will have add each V belongs to V to F, okay? This is the pseudocode. Okay? Now look. So I would pick a smallest weight. First of all, I will sort, and then I will sort the edges. Sort edges, okay? Sort edges. E belongs to E, edges, okay? I will sort the edges. So how many? The edges will be what? A to B, which is 1, okay? Which is 1. And then what? What's the smallest? B to C, yeah? B to C, 2. I sorted the edges. And B to D, 4. A to C, 5. And what's next? C to D, 10. Okay? So these are the edges. Sorting by the weight, smallest to the biggest. Make sense? If there are E edges, what's the time complexity to sort it, by the way? Sorting.
O-N, E log N.
There's no N, come on. There are E edges.
I said E log N.
There's no N.
E log E.
Yeah. Oh, E log E, okay?
I get used to N log N.
Yeah. We say N all the time, but if there's no N, you have to say which N is what. N is E at this age. If there
E log E.
Okay, O E log E. Or maybe O Eric or E log Eric,
Say
okay?
O Eric, say O Eric log Eric.
Okay, so now look, we sorted. Yeah, we sorted. And now, why the graph F is not connected? Why F is not connected? Yeah, connected. Now what we do? We remove. First of all, we remove the smallest edge in this case, which is 1, right? Right? 1. If it doesn't form a cycle in this F, okay, this is F. If this is not in a cycle, then we connect it. So 1, yeah. Put a 1, right? So the next one is B, BC2, right? We have picked this edge already, and then we pick this, BC2. We put it here. Okay, and then the next one, BD4, easy. Okay, so next one is a bit tricky. I need to pick one more edges. AC5, right? Look, for this AC5, look, I pick one, I pick this, I pick this. Okay, so now if I pick AC, that will have a cycle. We have a cycle here, right? And that will be, because we said we don't want the cycle, so we can't pick this. So we skip this, we skip this. So what's the next one? Oh, actually we already finished, yeah? Because there are 4 vertices, we only pick 3, right? Okay, so maybe this is not a good example. Maybe let's do another one, okay? E.
E.
And then we have, this is 2. We have this
There are already 2.
That's okay. And then we have here, and that's 7. Okay, let's use this example, okay?
We'll pick 1, 2, 4, 2. And
Wow. Okay, maybe you are right. Let's try, okay? Let's try.
oh, I'm out.
I need to change the value to a little bit. Maybe this I will put a 4 here. Okay, and then this will be 3.
Oh man.
Okay. So let's say this is A, B, C,
The biggest one
D,
you can get is 7, 3, 10, 5.
E.
2,
Okay.
4, 3, 4.
2, 4, 3. Okay. Okay. So how can
It's
we?
2, 4, 3.
Let's write this diagram to see if we.
2, 4, 3, 4.
So what?
It's
Let's solve the
13.
edges. Solve the edges. What's the
13.
B to C? B to C is 2, and then what's next? This 3, yeah. B to E is 3. What's next? 4. B to D is 4, right? Or A to B is also 4, right? It doesn't matter which one comes first. And then what? Then what's next? A to C 5, right? We sorted the edges. And what's next? 7, right? B to E. Alright? And what's next? C to D. Okay? So first of all, we start with these individual trees as a forest. We pick the smallest edge, which is B to C 2, right? B to C 2. Okay, B to C. So I pick B to C here. And then what's next? D to E. I pick D to E, which is what? 3. Yeah?
Yeah.
And then what's next? B to D, right? It doesn't still have, it doesn't follow the cycle yet. 4. Yeah? So this edge. Okay, next one. A to B, 4. A to B, 4. And oh, it still doesn't form cycle. So okay, so maybe I need to find a better diagram. Find a better example, right? Because we already find it, right? Huh? Okay, maybe I will change this to 40.
Oh.
So you don't pick these. Yeah, you don't pick these.
Okay, then that's 5, 2, 4, 3.
5 to
The
4.
highest you can get is 45, 10, 3, 7.
Okay, so A to B 40 will be here. A to B 40.
And you have to rub this.
Okay. So again, look at SN. BC, I pick BC, DE,
It's 5, 2, 4,
and
6.
BD. Okay, and so the next one I will pick A to C, right? You see, it still works, right? So the idea is that we don't pick an edge. If it's if this edge is already forming a cycle, we skip it. Okay, I need to find an example which does that. Okay, maybe I do this one more. Okay, so you see a better example. Okay,
I know.
A, B, C, D. I pick a better example. It doesn't have a cycle. F. So I pick a 1, 2,
I got teeth.
3, 4, 5, 6, 7. Okay, so for this one.
1, 2,
1, I pick a 1 here, right?
1, 2,
And the next one, the
4.
smallest will be 2.
4.
But now look, the next one is 3, but it has a cycle. So I skip it.
4.
1, 2, 4, 6.
4,
6.
and then
5.
5.
No.
No, I have a cycle.
6.
6.
6. And that will be, yeah? Because how many vertices? 1, 2, 3, 4, 5. 5 vertices, I need to pick 4 edges. 1, 2, 3, 4. Got it? Yeah? Okay. Okay, so look, this one is easier. I just said A to B. A to B is 1. A to B is 1.
Oh yeah, I'm getting
B to C is 2. And A to C is 3. C to D is 4.
1, 2, 3, 4, 5.
B to D is 5. And then C to F is 6. A to F is 7. Okay, so look, we pick this. But we don't pick this. This has a cycle, right? We don't pick this. 4, we pick this. 5, we don't pick this because it has a cycle. CF6, we pick this, and then that will be it because we already pick. That's 1, 2, 3, 4, 5, 6. We only need to pick 6 edges. No. 1, 2, 3, 4. We only need to pick 4 edges. 1, 2, 3, 4. Okay. Yeah. Make sense?
Yeah.
So.
Tick, cross, tick, cross,
So-
tick. Go.
So what? Every time we pick the edges, we merge 2 components into one, right? Right? Yeah. So how this is kind of greedy, right? So why is this? How can we prove this by this approach? It's the minimum spanning tree. How do you prove it? How does this work basically?
Just trying to get the smallest number.
Yeah, smallest number. Look.
With no cycle.
There's no cycle. Yeah. Look, every time we merge, merge 2 things. We pick the smallest edge. For example, this is E. We pick it. If we don't pick it, if we don't pick it, there will be some other edge which will have the cycle to this one, right?
Tick,
Right?
cross, tick, cross,
Am I right?
cross.
Am I right? Look, if you will try to.
Yeah.
So look, this is the edge we are trying to pick. If we don't pick this smallest edge, there will be some other edge going to pick to connect these 2 components, right? And if that edge is going to pick, they will have a cycle. And if it has a cycle, why not we just pick this edge? Am I right? Do you get it?
Yeah.
So this proves that this is a smaller minimum spanning tree. Okay?
Yeah.
Okay. And we can use what kind of data structure can we use to find if two vertices belongs to the same parent, same group? Remember we have learned data structure. Remember?
Disjoint set.
Disjoint set. Well done. Yeah. We have a group A B C D, and for the disjoint set we can check. We can merge these any two, or we can check if 2 components belongs to the same group. Yeah, we can check how many components connected, how many number of connected components, right? So this is done by disjoint set, okay, disjoint set, okay. So so what's the time complexity for this Kruskal? Remember? What's the approach? Yeah, sorting. Yeah, first of all we sorting, and then we need to find we need to find the smallest edge from what? We need to go through the smallest edges from the smallest to the biggest, right? And then find if these. So there's another operation which is we need to find out if 2 vertices belong to the same edge. And we can use this using the disjoint set. Okay, the time complexity for that bit to check if 2 vertices belong to the same in the disjoint set is trivial compared to the comparing to going through the edges. Okay, so the time complexity will be this one for the Kruskal. Okay, Kruskal. Make sense? Okay, I'm going to give another example and then you tell me what's the spanning tree and that will be it for today, okay? You both, okay? You both do it. Okay.
A, B, C,
Look at
D.
your car.
C.
A, B, C, D.
Look at your car. Look at your house.
Okay, so this is a tree. 1, 2, 3, 4, 5, 6, 7. Okay, can you write it? Can you write it? Come on. You want to try, Eric? No, please, you want to try?
Okay, so
This is
2,
B.
3,
No, you tell me.
5,
Well, A, B, okay, you tell me how to write it.
A,
A, yeah?
2, 3.
Okay, A, yeah, A, okay. And then what's next?
and then 2B,
To be, okay, this one, 2. And then what's next? 3.
Sorry, like this.
Yeah. Okay. Okay, I know what's next.
and then
Can we pick 4?
No.
Can we pick 5?
No.
no,
Can we pick 6?
yeah,
Yeah.
And what's next? Do we need to pick again?
no,
How many vertices? 1, 2, 3, 4, 5. So we need to pick 4 edges. How many edges have we got?
We have to get.
Yeah, that's it. Look, we have 1. No. If you learn, will be a cycle. So look, 1, 2, 3, 4. Okay?
Okay.
Yeah, make sense?
Yeah.
Okay. That's it for today.
Uh,
Bye bye. Bye bye.
Bye.